Hello, this is Miss Moore, and today during chemistry we're going to discuss writing formulas for ionic compounds. Today's essential question: how are ions combined to become electrically neutral? Okay, so formation of ionic compounds. So first of all, remember that cations and anions have opposite charges. Cations come from metals and are positively charged. And anions come from nonmetals and are negatively charged. And these opposite charges form an attraction. Remember that opposites attract, just like when we were talking about the atom, where the positive protons attracted to negative electrons. Same idea here, where the positive cations attract the negative anions. So these opposite ions, these opposite charges form an attraction, which will bind these oppositely charged ions together, forming what we call ionic bonds. So an ionic compound is an electrically neutral group of ions joined together by electrostatic forces. So electrically neutral means no charge. Again, we can relate this back to the atom. Remember, the atom is made up of positive protons, neutral neutrons, and negative electrons. We need to have the same number of protons and electrons so that the atom is neutral. The charges cancel out. The same things happens with an ionic compound. We need to have the same amount of positive cations as negative anions so that the charges cancel out. All right, so binary ionic compounds are made up of metal cations and non-metal anions. In a sample of an ionic compound, the total positive charges of the cations must equal the total negative charges of the anions, and that's so that the ionic compound will be neutral. So this is a fancy way of saying that we're going to have the same amount of positive and negative charges. That is what makes the ionic compound neutral. So formulas. A formula tells you both the types and the numbers, how many, of elements or ions in a compound. So an example would be H2O. That's a formula. It tells us the type of atoms involved. We've got hydrogens right here and oxygens here. Further, it tells us that we have 2 hydrogens and 1 oxygen. Subscripts are whole numbers, meaning 1, 2, 3, 4, 5, not 1.5 or something. So subscripts are whole numbers written below and to the right of an element symbol, and it is used to denote the number of atoms or ions in the formula. So for example, this is a subscript, that 2. The 2 tells us that there are 2 hydrogens. If you only have one of something, that means there's one. There's no subscript. So this says there are 2 hydrogens. And this one says there is 1 oxygen. We know there's 1 because we wouldn't have written it all if there were none. All right. So again, I keep hitting this point, but it's really important. Remember the idea of electroneutrality. Compounds need to be electrically neutral, just like atoms, meaning it has no charge. That means that you need to have equal numbers of positive and negative charges. You will note I said positive and negative charges, not the same number of cations and anions, but the same total number of positive and negative charges. All right, we are now ready to write formulas. So, how to write formulas for binary ionic compounds. This is the very important part of the lecture. Okay, here we go. So the first thing you need to do, the example we're going to use is sodium, which has a symbol Na, and oxygen, which has the symbol O. All right, so first step, determine how many electrons the metal should lose. Remember, metals lose electrons to follow the octet rule or to become like a noble gas, and write the symbol for the ion. So the metal is going to be sodium. So we've got our periodic table here, and here is sodium. And remember that the goal of every atom is to be like a noble gas. So he wants to get over to group 8A as far as the electrons go. So sodium currently has 11 electrons. His nearest noble gas has 10 electrons. So he needs to lose, sodium needs to lose 1 electron to be isoelectronic with neon. Okay, so sodium is going to lose 1 electron. And if he loses an electron, well, let's step back. Remember that sodium used to have, looking at the 11 there, used to have 11 protons and 11 electrons. If he loses an electron, he now has 11 protons and 10 electrons. So if he loses an electron, he has extra protons giving him a positive charge. Step 2, determine how many electrons the nonmetal should gain to follow the octet rule and write the symbol for the ion. So in our example, oxygen is the nonmetal. So let's check that one out. All right, so here is, sorry about that, let's put this back. Here is oxygen. He's going to gain electrons to become like neon. He has 8 electrons. He needs to gain 2 to be isoelectronic with neon, right? So if he gains 2 electrons, he now has extra electrons. So he is going to be O2 minus. So now we've written the symbol for the cation or the metal, sodium, and the symbol for the anion or the nonmetal, oxygen. Let's go on to step 3. Step 3 is write the cation and the anion with their charges side by side. I'm going to write it down below step 4 here. So we had sodium 1 plus and oxygen 2 minus. All right, step 4. Add more cations or anions as needed until the compound is neutral. We need to have the same number of positive and negative charges. All right, so if we look right now, we have a total of 1 plus and 2 minus. That is not neutral. So what can we do? How about if we add another sodium? Now we have a total of 2 plus and 2 minus. Now we have a happy couple because their charges cancel out. They're both noble and neutral. So what do we do now? We rewrite the formula with the correct number of ions as subscript. Number of ions, not the charge, because the charges cancel out. So Since we have the same number of positive and negative charges, these cancel out. So we're now going to write our formula. We have both Na and oxygen, but we have 2 sodiums and 1 oxygen. This is our formula. And that's really all there is to writing formulas. What I'd like to do, and I'd like you to do, is let's try a few more. If you feel comfortable, once I give you the practice problem, hit pause and see if you can do it correctly. All right, so let's get a little more space here. How about let's do calcium and sulfur. All right, so step 1 is figure out the charge on our metal, which is calcium. Remembering that they want to be over here. So calcium has 20 protons and electrons. To get over to the noble gases, he would need to lose 2 electrons to be like argon. So calcium loses 2 electrons, which means he has extra protons, which means he's positive. All right, sulfur. Sorry. All right, sulfur is our nonmetal. It's right here. He's going to gain electrons to be like a noble gas. He's going to gain 1, 2 to be isoelectronic with argon. So he is going to be sulfur 2, gaining electrons, means he's a negative charge. All right, next we write them side by side. I'll just squish them together. And we look at the charges. We have a total of 2 plus and 2 minus, meaning they're already neutral. So our charges cancel out. And the formula is 1 Ca and 1 S. Hopefully not too bad. All right, let's try one last example. Let me get rid of this stuff. May as well get rid of this too. All right, this one's going to be a really tricky one. Let's try aluminum and selenium. All right, so our metal is aluminum. So let's figure out the charge on aluminum. It's right here. Remember that metals lose electrons. So he's got 13. He's going to lose 1, 2, 3 electrons to become like neon. So he loses 3 electrons. If he loses electrons, that means he has extra protons, so he has a positive charge. And let's try selenium. Selenium is our nonmetal. He's right here. Nonmetals gain electrons. So he's at 34. He's going to gain 1, 2 to become like krypton. So he's going to be 2. He gained 2 electrons, which makes him negative. All right, so we have our cation and our anion. We write them next to each other, and we need to make them neutral. Currently, we have a total of 2 minus and 3 plus. What some people might think to do is write Se1 minus. Now we have 3 minus. You can't do that, though, because they need to be noble and neutral. If Se is 1 minus, that makes him like bromine. That doesn't work. So we can't do that. There's got to be another way. If I'm not sure what to do, what I start doing is adding more of the charge that we have the least of. So we have the least negative charge. So I'm just going to add another selenium and see what happens. Okay, so now we have 4 minus and 3 plus. That didn't work. But I now have extra aluminum. So let me just add another 3 plus and see what happens. I now have 6 plus and 4 minus. Darn it. All right, well, we'll add another selenium. Se2 minus. 2, 4, 6. I now have a 6 minus and a 6 plus. We did it. We have the same number of positive, total positive, and total negative charges. So the charges all cancel out. And we're going to write our formula. Our formula has ALs and SEs in it. It has 1, 2 ALs and 1, 2, 3 SEs. So there you go. That's how you write formulas. If you're comfortable writing ions, and if you're careful and calm, this is pretty easy. All right, folks, have a good one.